Let's do the polar bear problem. There's a polar bear. Hey, polar bear. All right, null hypothesis testing means test statistic, get the data. So the they weighed 50 polar bears. I like 50. It's like a standard deviation of S, but because it came from a sample size, we're going to call it the standard error, but we're going to use it like a standard deviation. And what else do we need? There's the stated mean, so that would be the population mean, and their sample mean was 43.9. So let's go ahead and go to town. Okay, so we have the data. Let's go through the process. Step 1, null hypothesis. They're just stating that the average is 45.5. And then the environmentalists are saying, no, that it is less than. Let's go ahead and find our test statistic with the formula. Plug in your data. Get a z-score. Let's go ahead and double check this in Excel. Pick a cell, any cell, go to the function bar. You're going to make sure you're in statistical. Scroll down to standardize. This is going to give you your z-score. And then the x is the sample mean, which was, okay, the x in this one is the sample mean. It's 43.9. And then the mean is the population mean, or the stated mean. Standard deviation divided by the square root of n, which is roughly 7.1. Click OK. Alright, we have the same z-score. Let's see what the area of a z-score of negative 1.34 generates. Let's look that up in our z-table. Negative 1.3. There's that row. And then the 0.04 row right there. So it looks like 0.0901. Let's double check that in Excel. Pick a cell, any cell. Formula bar. You're going to use, make sure you're statistical, norms dis, the one with the S in the middle. When you click on it, there's the formula. It's going to give you back the area from a z-score. So negative 1.34. We're looking for 0.0901. We have confirmation. So we know the p-value is 0.09. It's not great, but let's go ahead and answer the next question. Right? So the cutoff is 0.1 or 0.10, which is greater than 0.09. So at the 10% significant level, we can say, yeah, the critical value is greater than the calculated value, therefore we can reject the null hypothesis. Now what that's really doing is this. If the sample mean comes out to be close to the stated mean or the population mean, then the null hypothesis is probably true. But if the sample mean gets far away from the null hypothesis mean, that means that the null hypothesis is probably not true. So let's go ahead and check at the 0.5% level. So at the 5% level, it's just the opposite, right? The critical value is less than the calculated value, so you don't have enough evidence to reject the null. What they're trying to say is, did it fall within the confidence interval, right? The p-value. If it would have fallen within this range, then the null was probably true. If it fell without, if it was less than or greater than or not equal to, if it fell outside of this range, outside of the confidence interval, then the null was probably not true to begin with. That's it. MGZ out.